3.2, number 29. Let f be the function defined as that, where a and b are constants. If the function is continuous for all x, what is the relationship between a and b? So if it's going to be continuous, that means they have to meet. It's a piecewise function. This is a line, this is a parabola, so they're within these intervals, they're going to be continuous. The only question is, when they meet up, is it continuous? Well, if they have the same y value at that point, then it would be continuous. So we can find the y value of this one by plugging 1 in. You get 3 minus 1 is 2. So when x is 1 for the parabola, it has to equal 2. So a times 1 squared plus b times 1, that value has to equal 2 for it to be continuous. So we have a plus b equals 2. That's the relationship to make it continuous. Okay, so that's one equation. If we want it to be differentiable, there's two criteria. It has to be continuous, and they have to have the same derivative. Okay, so if you, just because it's continuous doesn't mean the derivative exists there, because it might be a corner or a cusp. We got a line and then a parabola, might look like that. It's continuous there, but it's not differentiable. Also, just because they have the same derivative doesn't mean it's going to be differentiable. So say the left looks like this, and the right might be a parabola that looks like this. So the slope at this point and at this point appear to be the same, but it certainly would not be differentiable at that point because there is a discontinuity. So it has to be continuous and they have to have the same derivative. Alright, so looking at this, it's linear, so we know that the derivative here is -1. Okay, so the derivative of this must also be -1 when x is 1. Okay, so we can find the derivative using the difference quotient. Minus all over h, and whatever we get here, again, when x is 1, it has to equal -1 because that's the slope of that line right there. Okay, so I think it's going to be easier to go ahead and plug 1 in right now instead of after finding the derivative. So I'm going to do that. So it's a 1 plus h so just doing some algebra here. So a plus 2ah plus a squared. Sorry, trying to keep up here. Over h, got a's are gone, b's are gone. You can take an h out of the top. I'm left with 2a plus ah plus b. And then we know that h goes to 0. So I get 2a plus b for an answer. And again, that's the derivative at 1, and in order for it to have the same left and right sided derivative there, they both have to have -1. So that's the relationship there. 2a plus b has to equal -1. So that's one equation. The other equation we found for making it continuous. So we could solve that system of equations. You could use elimination, substitution, you could use a matrix, but go ahead and do that, solve for a and b, and you should get your answer.